Hey everyone, it's CMAC here. I hope you're doing well. I know it's been a while, but I'm back and ready to create a lot of videos around DevOps, AWS, and software engineering. I was so busy with my career upgrade, which was a very positive change, and I'm excited for it. I cannot share what. And I also have a news that I passed all the AWS certifications, including Alexa, all 12 active certifications. Also, I got my Terraform and Kubernetes and a couple other things as well. So I'm so excited to build new content and help you all in DevOps and software engineering and build your skill set. Without further ado, let's learn Terraform. All right, so this course can be used if you're preparing for, Terraform Associate exam, or if you're preparing for a job interview as a DevOps engineer and you want to learn a little bit Terraform, or if you're just simply starting learning about Terraform. This is going to be a hands-on, demo, but I would like to share all the concepts that you need to know as a DevOps engineer in order to be comfortable with Terraform. So the way I decided to go with this course is, with this video, is to basically, instead of walking you through some of the basically slides or text, I decided to just share real links and real content from Terraform and AWS and walk you through all the concepts as fast as possible and then get to the hands-on part. Hopefully you like this way. Please let me know in the comment section. And without further ado, let's get started. So I'm sure a lot of you are familiar with infrastructure as code. A fundamental principle of DevOps is that we treat infrastructure code the same way developers treat code. So basically, we want to check in our code to a central repository. We want to be able to run, linting, testing, and make sure the quality of the code is high, and then we, deploy it and use it for our infrastructure deployments. So one famous tool that I'm sure you all have heard of it is AWS CloudFormation. You declare resources in JSON or YAML file and you deploy it to AWS Cloud. My favorite tool is CDK, that you can use programming language as an infrastructure as code language, where CDK will convert your code to CloudFormation template and deploys it to cloud, right? But in this course, we're talking about Terraform, and shortly you will see how Terraform deals with infrastructure deployments. But why do we care about infrastructure as code? Why do we want to do that? So there's a great article actually, and there's a great workshop on AWS website. You can have a look, infrastructure as code, and the first benefit is visibility. As you get to the next level in your business, as you add more people to your team, your code starts growing and the complexity grows, right? As complexity grows, you want to have visibility. Developers are deploying resources to cloud. You want to know who's deploying what to what part of the account. So visibility is the main problem if you don't follow infrastructure as code and you go to the accounts and start clicking around. The second problem is that process is just not repeatable. Stability is not just there. Things go wrong when you go to the web console. You click around. I click on one, and the other developer clicks on this. Another thing. So the process is not repeatable, right? So stability is another one, and scalability is a big advantage. Again, as your code grows, you get to hundreds of thousands of lines of code, and you have different clusters, you have different business units, you have different accounts. It just gets complex and just simply doesn't scale. Security, we always want to make sure we run a scanner such as, I don't know, CFNAG, to make sure that the template that you are building using CloudFormation, for example, is healthy, or TerraTest, or there's a lot of different security tools for Terraform, for CDK, for CloudFormation, to make sure that the code that we are building is actually following best practices from security perspective. And it's also transactional. When you deploy CloudFormation or you deploy Terraform, you will get some sort of a result coming back to you that the process was successful and this actually happened. The resource has been deployed, or failed. So you some sort of get a sense of your deployment process, and you always want to make sure it's in a good state. Wonderful. So I'm just going to close the first two and start talking about Terraform. So Terraform is a infrastructure as code. It's a tooling for DevOps to deploy your infrastructure, right? The good thing about Terraform is cloud agnostic, and in fact you can deploy resources to different cloud vendors, and you will see how using providers. uh, the files and directories, if we quickly take a look at the extension of Terraform files is just basically .tf. We'll take a look at registry, but for now, all I just wanted to show you is the extension of the Terraform files, right? So let's take a quick look at the core of Terraform workflow. Terraform talks about 3 steps. It says we write a code, we declare what we want to do, we intend to do, and when we can plan it, basically we can just run a command to simply see what's going to happen, and then at the end, if you're happy and satisfied with that result, we're going to apply it. So remember this if you're taking the exam. This is how Terraform approaches to the environment and to the infrastructure as code. If I scroll down, as you see, we have a repository, for example, here, and we're creating a main.tf file, and we're running some commands to initialize Terraform. We'll get to those commands shortly, don't worry about it. But for now, all I want to just share is we write things, we plan them to make sure we are actually seeing what we're expecting to see, and then if we're happy with that, we're going to apply those to code commit to our infrastructure. The way Terraform keeps track of all these information that you are building and you're planning to deploy, it keeps all of them in a file that called state file. And if I go back just to state file, unfortunately I don't have that state file. Let me just quickly go to state file. So the state file is a place that Terraform keeps all the information, and this is how Terraform tracks your real assets in the real account. The file name, please remember, it is called terraform.tf state. This is very important. So this is a state file that basically helps you deploy resources to cloud. Right now, imagine you change something in the state file. Now, if you deploy, that change will be reflected to a real account after running some commands and applying those changes to your account. But the problem is, in the example that I showed you, that when we look at Terraform process of planning, writing, planning, and deploying, every single time that you run that process, Terraform creates a TF state file and keeps the information locally, right? Because by default, that's the computer that you're using for deploying these resources. But what if I went back, right, and I started pushing those information to a central repository? The problem with that is, if I change and commit my changes to a central repository, and another developer pulls my branch and starts modifying the resources and deploys the resources to the cloud, and checks in all the files but the state file, so he or she forgets to just change commit the Terraform state file back to my central repository. So what will happen is, basically at that point you have a drift. The developer has deployed the resources, but he or she forgot to check in the TF state file. So having different TF state files on local machines, on different computers, on your developer machines is just doesn't work when you're working in a team. So the solution for that is a solution called backends, right? So what we want to do, basically, we want to create a centralized location to store the state files of our Terraform code, right? And S3 is one of them. Since we are focused on AWS here, we will be using AWS S3 if we want to decide to use the backend. And the backend will be shared, right, at that point using S3, and developers can basically check in the code, but the Terraform code is set up to use S3 as a backend. So I'm going to skip this setup at actually how you set up S3 as a backend for your Terraform code. But what you can do, you just can simply Google it, watch YouTube. There's so many resources that show you how to use S3 as a backend for your Terraform. And this is what you actually want to do in real life examples, because you don't want to keep state files in different computers. And there's a second concept called the locking. The locking is technically uses DynamoDB to make sure that two developers, when they're deploying at the same time, there's no collision, right? So you don't want to end up having resources that is getting modified by two different developers. So state storage and the locking are two you know best practices that you have to follow when you are setting up your Terraform environment for the first time, for your enterprise, for your company, for a serious project. As long as you have a team, this is definitely required: setting up your storage and setting up state locking. So these are the two things that you definitely want to make sure that you set up. All right, we talked about that, and I'm just going to move on here, but make sure you read this page if you are taking the exam. All right, so let's close this. But how does Terraform actually talk to cloud provider, right? Terraform provides a concept called provider, and there's so many of them. You can actually build a provider for your own, right? And Terraform interacts with remote systems using these providers. For example, for AWS, we do have a provider for AWS. For Microsoft Azure, we have a different provider. So and note that name equals source and version syntax for required providers was added in Terraform version 0.13. Make sure you know the difference between version 0.12 and 0.13. All right, another part is the best practices for provider version. Basically, you use greater or equal. This is how you declare the minimum version for your Terraform provider. And there's also a tilde, and make sure you know the difference between tilde greater and greater equal. So let's move on to the next topic. The great place about Terraform is Terraform registry and the community and the people who are building these modules, reusable components that we don't like to build every single time. For example, if you are building VPCs, you don't want to rebuild VPC every single time, right? Or if you're building EMR or Kubernetes cluster, you don't want to reinvent the wheel every single time. You just want to use reusable components, and those components can be pushed to Terraform registry, right? You can build a new module and push it there, and people can start using it. As you can see, there are almost 1900 providers. There are 8500 almost modules and counting. This is a great, powerful place to find sample codes, to find resources for your project. So modules are technically reusable components, and we'll get to it shortly. So if I click on AWS, you will see there's so many modules for AWS. For example, EKS, Terraform module to create an Elastic Kubernetes cluster and associated with worker instances on AWS. This is not something you want to build every single time. And if you look, there's just provisioning infrastructure. It says copy and paste into your Terraform configuration, insert variables, and run Terraform Init. That's it, right? And if you want more, you can just start scrolling down. You will see every single step that how to use this module and what version of the module you want to use. And then you just define what you want to deploy. You provide the configuration with the VPC ID, and the rest is just will be handled by Terraform. So don't be intimidated by the length of this code. This is so simple. I'll show you quickly how to read Terraform code. The concept behind it is actually quite simple. Once you start building different resources and using modules, you will see how easy it is to just use these nested objects and build components using Terraform. All right, so I'm going to close this and go to the couple commands that Terraform actually wants you to know. The first one is initialize command. So when you want to start a new project, you want to initialize the project, right? And the way you do that, you use command Terraform space init. So first of all, I'll show you where to download. You can just simply Google Terraform download. I'll show you the link, but you can just download the Terraform and install it on your Mac, Windows, or Linux. I'm just going to skip that, and I'm assuming you already have Terraform installed on your computer. So Terraform Init, as I said, it will start and create your Terraform project, right? One thing does copy a source module, right? By default, Terraform Init assumes that the working directory already contains a configuration and will attempt to initialize the configuration. So you create your configuration first, and then you run Terraform Init, right? Remember, if you're taking an exam, that the backend initialization happens during Terraform Init phase, right? And also child module installation also happens during that time. So during init, the configuration is searched for module blocks, and the source code for reference module is retrieved from the locations given in their source argument. So remember, when you are running Terraform Init, this stage will happen there. And last but not least is the plugin installation. So remember, most Terraform providers are published separately from Terraform as a plugin. During init, Terraform searches and downloads and installs those plugins. So three things when you start a project, you do Terraform Init, and Terraform Init will install the plugin, child module installation, and backend initialization. So if you change your backend from local to S3, you need to rerun Terraform Init to make sure the S3 gets set up, right? So don't forget to do that if you change your backend. All right, let's close that. Plan is a very great tool, and I definitely recommend highly that you always use this before running your apply. It technically just shows you what's about to happen. You might be removing resources from account, or you might be adding a EC2 or maybe EBS volume. So Terraform apply is a command that will be used after Terraform plan, because plan doesn't actually deploy resources to your AWS account. What it actually deploys is Terraform apply command. So take a look at these options, Terraform plan, and make sure you know that planning mode, there's a destroy mode, right? And there is also a dash refresh only. Create a plan whose goal is only to update the Terraform state. So there might be scenarios that you want to update the Terraform state file. Make sure you know how to do this, dash refresh only. And this creates a plan. Its goal is to destroy all remote objects that currently exist, right? And leaving an empty Terraform state. There's one last thing in this page, and that is input variables on the command line. So when you run Terraform plan, you can actually supply some variables on the fly, right? And this is how you pass basically input variables to your Terraform file. All right, so let's move on. Now let's say you are working for a team, right? You have created your Terraform file, and now you're ready to just add that to your local repository, to your local or remote repository. Before you do that, you want to make sure your code is well formatted and it looks nice before you push it to the central repositories and have your manager look into it. So always make sure you run Terraform FMT, which is Terraform format, and will nicely format your Terraform. All right, as I said, Terraform apply just applies the resources to the account based on the state file that you have, right? Or based on the plan that you actually created. So this actually deploys resources to account. And remember, that's the difference between plan and Terraform apply. There's also the dash auto approve option that you can pass and add at the end of the Terraform apply command, because if you run Terraform apply, and we'll run it shortly, you will see that's going to ask a question: are you sure you want to apply this changes? You have to type in yes and hit enter. This dash auto approval basically bypass that approval process, and it's good when you are using actually CI/CD pipeline to deploy Terraform to, for example, target accounts, because there's no one in the pipeline who can actually type yes. So if you want to inspect the plan before applying it, you can use Terraform show. Make sure you know all these Terraform show and all these commands. These are very, very important concepts for probably your exam and your as well as real life experience. Cool. So we'll close this page, and another command is Terraform destroy. Obviously, this destroys the resources from your account. Please use this command carefully. This is a dangerous command. If you run it against an account, this is going to destroy actually the accounts. That's why it's always recommended. You can also create a plan and to see what the effect of destroying would be before running that, right? Make sure you always run Terraform plan dash destroy to see, oh, I'm about to remove my RDS database. I probably don't want to do that and cause downtime for the company. So make sure you always inspect your plan when you're destroying real resources from accounts. Last but not least, the taint command. So imagine I have an EC2 instance and I deploy that EC2 instance and somehow in a bad state, let's say it's failed, it has an error or something. So taint command allows you to taint a specific resource. And that means basically Terraform attaches a label, puts a label on top of that resource, and it says, okay, next time when you run the apply, remove and replace this resource. Make sure you understand how the resource addressing works based on the basically index of the instance, for example. Cool. Oh, sorry. One last command, and Terraform validate. The Terraform validate, it just checks your validity of your template. It just double checks, to see if there's an error, there's a problem in your template. It doesn't actually check if you're, for example, passing a wrong security address or wrong VPC, or you're doing something wrong in the account. It doesn't validate that. All right. One important concept. Now, imagine you're working for a company, right? And that company has dev account, beta account, and prod account, right? So if you use one state file, between all these environments, and the moment you run Terraform apply against, for example, beta account, it's going to replace the content that you already had for the dev. And if you do that for prod, it's just going to replace this. So you cannot share the state file between different workspaces, between different environments. What you want to do instead, you want to create different workspaces. For example, one for dev, one for beta, one for prod. And Terraform comes with a default one that you cannot delete. Remember, you cannot delete the default workspace, but you can create new workspaces. For example, Terraform workspace is new and then followed by name, and then Terraform workspace select, you can go to dev, come back to prod, so you can select the workspace that you want to work with. Now when you check into a specific workspace, you can make adjustments, and when you apply Terraform apply, basically you're updating the state file for that specific workspace. And then let's say from prod you go back to dev, then now you're working with the state file that's connected to your dev environment. So think of it as a container that you're separating different environments, and it's a separation of concern, which is a great way of dealing with multi-account or multi-environment setup. For example, here's a condition that we're saying: if I'm on the default workspace, use 5, otherwise use 1. This is just like a sample if command that decides if the value of the count, if you want to deploy 5 instances or 1 instance. And even when you're naming when you're naming your, for example, web server, you can say, okay, web-dev, web-prod, web-beta. So it can be selected as a variable on the fly in your Terraform template. Cool. So these are the things that I wanted to talk about. And remember, again, the name of the file that you keep your state is called terraform.tf state, right? For local state, Terraform stores the workspace state in directory called terraform.tfstate.d, and it will create and this directory should be treated similarly like a local one that you have. But remember that when you work with workspaces, you will see this folder structure and folder naming in your Terraform project. Wonderful. All right, so for logging your Terraform, so when you run Terraform Init, by default, all the logging and all the details are hidden. But what you can do, let's say you run into an issue and you want to, just take a look at the result and see what's happening, what's going on. You can just use tf_log and set it to trace. And you can easily, after running, for example, Terraform Init, you can see how your environment Terraform tries to connect to S3, the connection, establishing the connection, and if there's a error or problem, you can easily log that and use tf log. So this is very great and useful command, by the way. So we talked about state. Make sure you read this page completely and you understand how exactly these commands work. State is a very, very important concept, and it's just a map. It's a blueprint. It's a place where Terraform keeps all the information and maps it to the real account. We talked about backends, and please make sure you read backend page if you're preparing for exam. We talked about state locking. Make sure you read and you understand all these concepts. We talked about workspaces, and one thing I want to talk about is the structure of a Terraform project. So when you work with a Terraform project, you have a main Terraform file, which technically has all the things that you need to deploy resources to an account. Let's say VPC, EC2, right? You can pass some variables to these main file, and it automatically passes a variables.tf file, and you can have an output. So imagine main is a box that has an entry and input and has an output. So this structure is actually a very great, works really good with all the projects, even heavy projects. And the reason for that is you can repeat the same process for every single module. Let's say you have a very large project that has the main Terraform structure, and then underneath it comes with some modules, and the modules can have you can have sub modules, nested modules. So they all come with the same structure: main variables output, main variables output. So now if you are designer of this module, you can simply create main variables outputs with a readme file and push it to the registry, and other people can come use it, right? So make sure you always follow best practices, and this is a recommended way of storing file and folder structure for your Terraform project right here. So main variables.tf and outputs.tf. There are other files that we can talk about, such as passing AWS secrets when you set up your connection to AWS, but that's just one way. We'll quickly get into that when we get to the hands-on part. All right, so modules, reusable things. Remember, when we talk about modules, we're talking about reusable things. You can have child modules, and remember how passing information between parent and child module works. This is a very important concept in real life and as well as your exam. I want to quickly talk about dynamic blocks. This is actually a very useful concept. And if I scroll down, as you can see, a dynamic block acts much like a for expression, right? So imagine you have like a dev, a beta, and prod, and you want to, basically set up these variables, like such as name, value, namespace, couple of things. And you have to repeat that all the time, right? And you don't want to keep putting duplicate information with different values. What you can do, you technically can create, something like for loop, which dynamically fetches information and provides information based on the specific environment that you are on. If you look at that best practices section, it says, so we recommend using them only when you need to hide details in order to build clean user interface for reusable modules. So this is great. You can just simply iterate over some block variables and feed them to this dynamic block. So make sure you use them. Built-in functions. Terraform comes with a lot of functions, right? You can find the list on Terraform website. I'm just not going to go through all of them one by one, but if I open them, you can see minimum, maximum, all the string functions like join and so many things. So for example, if you want to find a maximum, but remember these functions are defined by Hashicorp. You cannot create function in Terraform, and that's something you need to remember. Let's close that. And Hashicorp Walk, just make sure you've heard of this service by Hashicorp. It's managed secrets and protect sensitive data. So basically, you can secure and store, your tokens, password, certifications, keys, everything using a tool called Hashicorp Walk. In fact, they have their own certification path that you can get certified. Up to now, we are talking about Terraform open source, where you run Terraform locally and creates a state file and all the great stuff. So as you get to more enterprise level work in the real world, and you join a company or you're working as a DevOps professional, it might be challenging to keep your Terraform environment based on the resources and engineers that you have on the team. There's an option called Terraform Cloud. It's basically HashiCorp managed service offering, right? It eliminates some of the overhead that you need to manage in your own workflow. They provide all these things such as having a backend. For example, if I scroll down, you see it says private registry, safe block, and you commit it, and then here you see all the workspaces, and it works really good with all the cloud vendors. So make sure you have a look, and you always have these options in your mind that okay, it says build infrastructure remotely with your team. Cool, it says remote state storage, flexible workflows. You always want to make sure you consider all these options when you are picking a specific distro, right? Distributions are very important. Right now we have Terraform open source, and Terraform Cloud and Terraform Enterprise. In fact, for Terraform Enterprise, there's a cool, if you search Medium, you will see this article that talks about the difference between all these tools. And what I want to just highlight here in Terraform Enterprise, you have, for example, private module registry where you can submit your packages, right, and just publish them to your private registry. You can have 100% state management, workspaces, Sentinel. Basically, it's integrated policy as code where you can define policies and it will ignore creating those while you're as you're building. This is a great way of building policy as code. Sentinel. And this is a great read. Have a look and make sure you understand the difference between Terraform Cloud, Enterprise, and open source when you are picking the right technology for your company. As we are getting closer to the demo, I want to quickly share a couple things here. Okay, so up to now, we talked about that you go to your computer and you run a command. You says Terraform Init and Terraform Pipeline apply. But in real work, actually, you don't want to do that. You don't want to run commands from your computer. You want to automate the process as much as possible. Building an infrastructure, continuous integration, CI/CD pipeline, and where you can use tools such as TerraTest to test your code before actually deploying it to the account. And the idea is simple. You have a code commit repository where you check in the code, there's a pipeline, and there's a code build project that does handle all the Terraform apply commands to the target account by assuming a role in the target account. TerraTest is a great tool, and you can click on it, learn about it, and as you can see, write test code using code. This is a very good testing code for Terraform, and as you can see, there is a sample that how you can use it. So remember TerraTest, CI/CD pipeline when you're working with a real world project. This is a great way of doing things. Sometimes you run into scenarios that you have to deal with multi-account environment, and you want to make sure you enforce security and you have governance in place, that you have multi-account strategies. For example, your company has 100 developers. You want to launch separate accounts for developers. You want to make sure they don't launch EC2 instances, 10 EC2 instances with X large and incur large costs. So you want a central place to control and monitor your environment, and that is a service called AWS Control Tower. It's a large topic on its own. I'm not going to go through it, but what I want to just mention here, that AWS Control Tower is a place that where you can manage hundreds of thousands of accounts in large organizations, in SaaS applications, in running workloads. So this is a central place that you can monitor your AWS environment. And AWS Control Tower comes with a solution that's called customization pipeline, and this customization pipeline is basically a place where you upload. It's a GitOps model. You upload your infrastructure. Let's say all the accounts, they need to have a specific VPC. You just check in your VPC here, and you let the pipeline to deploy to all the 100, 200 accounts, 500 accounts. You don't want to go and run the commands one by one. And the technique that AWS customization pipeline uses is step function. And a step function is basically, it's an orchestration engine that can run, hundreds of, tens of hundreds of processes at the same time, and can have an aggregator that gets a result for every single account. So this was a cloud formation. If you notice, it's a cloud formation template. You can download it and deploy it to your control tower, and technically deploy resources to all the child accounts. Let's say you have dev, beta, prod for 6 department of your company, total of 18 accounts. Tooling, developers, let's say you have 50 accounts. And if you want to deploy an S3 bucket or specific IAM role to those accounts, this is the solution you could use in order to deploy those resources. However, recently AWS announced that in November 2021, based on this article, that you now can use Terraform to deploy resources, and instead of CloudFormation. So Terraform can be used. It's called AFT, the solution, AFT, and Account Factory for Terraform. It's the same concept, uses step function, but right now you see instead of CloudFormation, it uses Terraform. It can either integrate with Terraform Open Source, Terraform Cloud, and Terraform Enterprise, and can vend account and create everything that you need. Let's say you onboard a new customer, you can vend a new account using this configuration. But the point being here is Terraform is now supported in AWS Control Tower. Wonderful. 3 more topics, and then we'll get to a hands-on demo. And one of them is data source. Data source, as it indicates, it's provides data, right, from configuration, from or from another file. If we quickly take a look, and we're going to create shortly, a Terraform file, you will see I have a data, right, and the type of that, it's AWS AMI, right. By the way, you don't have to remember all these things. I'll show you how to search and build your infrastructure step by step. It's very easy. And then you name this resource example. So you have a data, and then here's the pattern. You have a data or whatever you're trying to do, and then followed by the resource type and followed by a name. And then within curly braces, you start just providing the data block. So I have a data block, and the data block says most recent equal true, right? Owner, myself. What tags I want to apply. So this is a block of data, a box that you put some data in it, and you can ship it to wherever you want in your Terraform code. Very simple. Another one is variables and outputs. So variables, it's very simple. Let's say I want to provide some variables for my Terraform, and again, as you can see right here, I have a variable, and here's a variable name, right? And this is the type that I define. We'll get to the types right now. And another variable called availability zone names, and the type of that is a list. List means collection of things, right? Collection of strings. This is list of strings, and the default value, if you don't provide, is just going to pick US West 1A, right? And California region AZA. So remember that how we define variables. For example, if you're working with Docker, Kubernetes, and things like that, you can define a list, and you say, okay, I have an object that might contain different type of things in it, right? It has numbers in it as well as string. So this is how you define it, and you set up a default in case the user doesn't provide it. These are going to be the default setting of your Docker, variable, for example. Excuse me. So I want to quickly just talk about the type constraint, that what type of variables you have. You have string, number, boolean. So string, number, boolean can be just your name, can be the AMI ID, number 1 2 3, boolean, true and false. You can have list of things, list of string. You can have set of things, and you can have map. You can have object, and you can have tuple. Let me close this. We talked about input variables. Let's talk about quickly about the output one. So you can also define output. You say, okay, at the end when you deploy, I want to have an output, name my variable instance IP address. I want to know the IP address of my instance, and just we'll reference the AWS instance, and we say my server and get the private IP, and you set the value. You will see how to explore these documents to find all these information. There's also a sensitive flag property that you can add. Terraform will hide values marked as sensitive in the message from Terraform plan and apply. But remember, these will be still clear text in your state file. This is a very important concept. All right, that is what I wanted to share in terms of variables. Resource block. At the end of the day, we want to deploy resources to cloud, right? We want to deploy ALBs, S3s, IAM roles, AWS instances, and all these resources they exist in the documentation. So again, you saw in the data section that we defined that keyword in this scenario is resource, and then we say what type of resource we want to order from the library, and we want to name it. And then you provide some properties such as AMI ID, type of the instance, and things like that. So this is very, very simple, to be honest, in terms of managing. But let me quickly show you how to take a look at AWS provider. So if you go to the registry and to take a look at AWS provider, the reason I say it's super easy is I'm just setting up the Terraform required version at AWS. I'm defining my region. I'm saying my provider is AWS and deploy to US East, and I want to order a resource from AWS VPC and call it example. And the CIDR that I want to create is this. That's pretty much it. So by deploying Terraform Init, Terraform Apply, you're going to create a new VPC in your account, right? So let's scroll down a little bit. In order to authenticate, this is the part that's important since we're about to set up our account and deploy a resource. So in terms of authentication, there's so many different ways for authenticating with your AWS account. One easy way is just to create a IAM user and create the access key and secret key and just inject them in here, and you start deploying things to your account. One another way, there are best practices that I want you to follow. One way is technically using environment variables, right? So environment variables, we are exporting these values as a environment variable, and when we run Terraform plan, basically Terraform is going to use all these, and it's not going to commit anywhere. There are other options such as using shared configuration file, and there's some also assuming an IAM role. As you can see, you can assume an IAM role. The best way of using accessing AWS accounts is using IAM roles, but for the purpose of this scenario, we're going to be creating an AWS access ID and access key, and we're going to start deploying resources to account. But please do note that IAM roles are another option to use and deploy resources to AWS. Now, if you look at the left side, you can see every single resource that you can name, we have a sample for IAM role. So, all right, this is resource. I want to order IAM role and I want to test this role. And here's the policy that I want to attach it, and I want to add some text. As simple as that. So you just find the resource that you want to deploy. You look at the pattern, and the pattern is always resource followed by the construct, the component that you're trying to deploy, and you give it a name, and you just put some values in there. All right, let's move on. We'll keep this page open as we're about to deploy some resources to our cloud. So if you look at my example now, I mentioned that when we create a new project, we create a main file, right? Touch main file, it creates just an empty main.tf file, and we said we're going to name all Terraform files. The extension is .tf, and as you can see, I have a Terraform, and the required version is defined. Remember, in version 0.13, this is the format, and this is saying deploy to US West, and it says deploy an AWS instance to there. I'm just going to copy this because I'm going to use this example and with other couple examples to deploy resources to my account. All right, make sure you have an AWS account. Make sure you have billing alerts set up, so in case if you pass your budget, you will get a notification. If I go to IAM role, what I'm going to do, I'm going to create a user. I'm going to name this test. Actually, I'm going to use this Terraform user, and I'm going to give it access key and access ID. I'm going to say for now this person is administrator, and I'm going to next. All right, I created access key ID and secret access key. This is the only opportunity you can copy. As soon as you close it, you're going to lose these, so make sure you make a copy of your own access key ID and secret access key. By the time that you're watching this, I've already removed this key from my account, so please do not use these values as they're not going to be valid. I'm going to use Visual Studio Code, and I have created an empty folder called Terraform Course, as you can see, Terraform Course, and I'm going to create in Terraform Course a new file, and I'm going to call it main.tf. And as you can see, it's recognizing my extension variables.tf, and I set output.tf. Remember, there were 3, and now let me close this. It's going to confuse me here. And you can also create readme.md. Wonderful. So this is my readme file. You can always right click and preview it, and this is your main file. The entire Terraform code. Variables, we talked about that you can pass variables, and output is the place where you have the outputs, right? So one extension I want to make sure that you install, and if you go and install and search for Terraform, please make sure you install the one from Hashicorp, and that highlights your commands. And if I go to command installer, you see 1 million downloads. This is from Hashicorp itself, and the good thing is, as soon as you start typing things, it will automatically show you a lot of hints and great information, and it makes your life much easier. So let me go back to right here, and I want to copy the IAM role that we talked about. Right, I want to come back to this main file, and I'm just going to paste this to my document. What I'm doing, I'm saying I need a resource. It's an IAM role. I'm going to name it test role, right? But if you recall, when I said when you start a new project, the first thing you need to do is to Terraform Init. So I'm going to do that. This is going to initialize and download all the required information for my code to work. One thing I need to do is my terminal currently doesn't have access to my AWS account. What I need to do, I need to the credentials and keys that I created, I'm just going to inject them as a environment variables and export them, or you can create just AWS configure and use those as AWS configure inputs. Let's see which one is going to work. Okay, so perfect. So as you can see, my project has been initialized. All right, our Terraform template is ready. And as you can see, it's an IAM role called test role. And here's the name that I'm providing. This name is actually the name that you'll see in the console. This name that you see, it's actually to reference this construct within my Terraform file. So if I have a Lambda role that is referring to this resource, it's going to use this part. So, but the name actually that you will see in the console for the IAM role is this one. So don't confuse why we have two. And then you have a JSON to code command that you can just simply paste a simple AWS policy, in this case AWS STS assume role, and I'm adding just a tag to this. Cool. So let's see if I run Terraform plan, what will happen here. All right, the reason this did not work is my AWS communication is broken. I have not configured the key that I created for my environment. So I'm going back, I'm going to type in AWS configure. Awesome. And I'm going to paste the values. I'm going to copy this as well. Come back and paste this. It's going to be US West 2. Right, this is my region. And I'm just going to hit enter on the output format, default JSON. I'm going to clear this. I'm going to rerun my Terraform plan once more. So since my Terraform plan right now has access to my AWS account, now I can go ahead and close this, in fact. And since I don't need it, I'm going to remove it at the end of this video. Now you can see Terraform plan went ahead and said, okay, plus create, I'm about to create a new role, and that is an IAM role. It's called test role and has some features. And as you see all the pluses, which means we're going to add something to our account. It says plan to add one resource, 0 destroy, 0 to tame. I am ready to deploy this. So I'm going to run Terraform apply. Terraform apply. All right. And as you see, I could technically add dash auto approve, so it doesn't ask me to approve it here, but I'm going to say yes right now. But in the pipelines, you want to have that as a parameter so it doesn't wait for you to add. There you go. So it's easy. It says I added a resource to our account. Before I go ahead and check my real account to make sure the IAM role has been deployed, I want to make sure you understand that there is a file right now. As soon as I ran the Terraform apply, that's called tf terraform.tf state. This basically this is our state file that keeps track of all the resources in the account. You don't want to modify this file manually, remember that. But as you can see, there is a IAM role that we have deployed to the account. This is technically a map of what's actually sitting in your account, but it's not the resource itself. This is just a map. So now imagine if you have 100 developers and they have different state files on their local machine, meaning they all can introduce bugs and errors to your account. That's why you want to always have Terraform backend set up for your real project. So let's say instead of EC2, I gotta say, for example, Cloud Watch. So I changed the resource to CloudWatch. Now I'm going to run Terraform plan. So changing the service principal, it's a major change. It's something that's actually, I'm telling Terraform that I am going to change the principal. Whoever is going to use, it's not the principal is not going to be EC2. CloudWatch moving forward is going to have access. This is a critical change, right? It's not like changing a name that's managed by a random character and the end of the role. And as you can see, Terraform detects that you are changing that, and I'm ready to apply that. Apply, and all right, and it's going to be test role. So what I'm going to do, I'm going to destroy this, Terraform destroy, and let's destroy this resource. Looks like I misspelled. Now Terraform is going to ask me, are you sure that you want to destroy? I'm going to say yes. As you can see this time, there is a red sign that says it's going to remove this from your account. Are you sure? I'm going to say yes. And if I look at the account, my test role should be gone shortly. So while that's deploying, while that's removing, let's take a look. And now it's gone. So what I'm going to do, I'm going to clear this file. And I'm going back to my another example that I have from the Terraform Hashicorp website. All right, so I'm just going to copy and paste this file right here, and there it is. I have a Terraform required version. I'm using AWS Terraform, and my region is specified, and there is an app server. And I'm saying I need to order an EC2 instance. All right, so without running or changing anything, I'm going to just run Terraform plan. Now you understand how easy it is to find resources and do all these. So since I changed the required version in this new Terraform template that I'm about to deploy, I wanted to introduce this error so you see how it can be resolved. So if you see that I can, the reason is I initialized that with 4.4 sorry 0.13, and this says the required version is this, but you don't have that. So what I'm going to do, in fact, I'm going to just copy my version. I'm going to save that, and I'm going to plan it again. I want to make sure that I'm using the same version. Let's say I want to go ahead and deploy this Terraform apply. It's going to ask if I want to proceed or not. I could just pass dash auto approve, but I'm going to just type yes. And I'm going back to my AWS account and going to EC2. Please make sure after deploying all these resources you run destroy, so the instance doesn't just sit on your account, because it's going to cost you money. So I make sure I am in the right region. I'm in Oregon region, US West 2, which is great. And I am going to remove the filter. As you can see, there's a pending instance that's about to start, and it's called example app instance. And you can now understand how easy it is to use infrastructure as code to spin up infrastructure. And Terraform is deploying, and deployment is done already. This was much faster than clicking on things. And there it is. This is my EC2 instance using T2 micro, and it's all up and running. Let's see if I can open the address. Well, this is deployed to a default VPC. I'm not sure about all the IGW, and because my default settings are not just properly defined here. The point is, I just wanted to show you how easy it is to deploy a EC2 instance to an account. I'm going to go back, and I'm going to say Terraform destroy. It's going to ask me, are you sure that you want to remove? I'm going to say yes. As you can see, all the red signs, it's telling me that I'm going to destroy this resource. Are you okay with it? So please always run the plan before doing that. But right now, since this is a test, I'm just going to go ahead and directly type destroy. And this is going to quickly shutting down and destroy my. So the communication between my Terraform and AWS account is happening via that provider that we talked about at the beginning of this video, right? So this is the provider, and I'm saying the default value is this. So now what I wanted to quickly show you before finishing this video is I want to go back to, for example, to an S3 and see if I can find S3. Let's say I want a create a S3 not bucket policy, S3 bucket. There you go. Okay, here. So here's an example. Again, you don't have to remember these resources. It just follows the same pattern. Resource followed by what you want to order from the inventory, and then you name it. And here's the bucket. You can add some tags, and here's an ACL. So I wanted to show you quickly how to connect these connections together. So I'm just going to replace what I have here. So in here, what we're doing, we are telling Terraform that, okay, I have a resource and that's S3 bucket, and here's the name of the bucket. Just make sure the bucket is random. And in the second one, we want to say I want to set up ACL for the bucket that I just created. So if you want to reference the resource in your Terraform file, you can say S3 bucket, the name of the bucket that's defined using Terraform, not the actual name within the block. It's how you label it. So resource and the name of the resource for Terraform reference. Get the ID of that Terraform S3 bucket that you just created. So this is how you reference an S3 bucket ID, and you pass it to the ACL, because you need to set up a ACL for a bucket, access control list for your bucket, and you need to reference the bucket name. And this is how you reference the bucket to your account. So I'm going to save this, I'm going to say Terraform Cloud. All right, and it says I'm going to add two new things to the account, which makes sense. I'm going to say Terraform apply. There you go, and I'm going to say yes. And this is going to deploy in S3 buckets. It says the request bucket name is not available, which makes sense. CMAC S3 bucket. I'm going to save this. Terraform apply. I'm going to change the bucket name. All right, bucket created. Since the name is unique right now, I'm going to go back to, let me just rerun this. Yes, as you can see, right now my EC2 instance has been terminated. Let me go to S3. And in S3, we have a bucket. Now I'm going to clear the page. I'm going to say Terraform destroy. And this is going to say, are you sure? And I'm going to say yes. Wonderful. And if I refresh that, bucket doesn't exist. So before we wrap up this tutorial, again, I want to make sure you have access to AWS documentation. You see in the Terraform registry, in every single resource that you can imagine, it exists here, and there's an example for it. I want to set up SNS topic. This is how you set it up. Example of delivery. This is how you use it. Example of server-side encryption. It's right here. So you don't have to actually remember all these different tricks that people talk about. All you need to know is that there is a place in documentation. You can just go there and you can say, okay, I want to go to license manager and I want to create an association. There it is. So you can just create a license here. So it is super simple to actually start experimenting with Terraform. It's a tool that as a DevOps engineer, you need to understand and know how it works. All right, I hope you enjoyed this video. Make sure to like and subscribe this video, and I hope to see you all soon. Bye.